So this problem is from 8b, and in 8b we're talking about doubling time and half-life. And this particular problem says the initial population of a town is 4,200, and it grows with a doubling time of 16 years. And then it says determine how long it would take the population to quadruple. So this is a doubling problem. And so let's talk about this doubling problem, and let's kind of make out kind of like what will happen, because we can do this. This is not that many years. We know that initially, so the initial year, it's 4,200. The doubling time is 16 years. So the doubling time means that when you take the initial time and you add 16 years, so let's just say the initial time was the year 2000. Well, then in 2016, this population would be 8,400. And then if you added another 16 years, so let's say it was the year 2032, that's 16 years later. Now the population of this town would be double this prior number. So it's going to be 8,400, and double that would give me 16,800. And then if I did another 16 years, so that would be 2048, you would add, it would double again. So it would double again, and it would look like this. So that is what is happening each time. So now it would be 33,600 each doubling time. Now, but the question asks, well, determine how long it takes for the population to quadruple. Well, quadrupling means that you're going to take the initial population and you would quadruple it, which means to multiply it by 4, or take 4,200 plus 4,200 plus 4,200 plus 4,200 is the same as multiplying by 4. And so if we multiply by 4, let's see what we get. So 16,800, which is here, which is in year 2032, which would be 32 years after the initial population. Now, I know the problem did not pick the year 2000. I was just doing this for the ease of the years instead of starting it in 2024. I was just saying 2000, and then so I can add 16 easier. So, but the problem did ask for how many years, so it'd be 32 years. And so that's how you would approach this type of problem.